Hi, welcome to the video training of Elixir, and in this video training we will be looking at pattern matching. So we will show how the equal operator in Elixir is actually a match operator and how to use it to pattern match inside data structures. Finally, we will learn about the pin operator used to access previously bound values. Okay, let's look at the match operator. We have used the equal operator a couple of times to assign variables in Elixir. So first of all, let's get into the Elixir interactive mode, that is IEX, and here we are in the interactive Elixir mode. So as we have seen in the previous video trainings of this series, we can assign variable values to the variables using the equal operator. So x equal 1 is 1, and if I type in x, I get 1. That is the value stored in the variable x. In Elixir, the equal operator is actually called the match operator. Let's see why. So we ran x equal 1, it gave us 1. So what if I ran 1 equal x? It gives us 1 as well. But if I type in 2 equals x, it gives me match error. No match of right hand side value, that is 1. Notice that 1 equals x is a valid expression and it matched because both the left and the right side are equal to 1. When the sides do not match, a match error is raised. A variable can only be assigned on the left side of equal, that is 1 equals unknown. So if I type in 1 equal unknown, I get undefined function message. Since there is no variable unknown previously defined, Elixir assumed you were trying to call a function named unknown, but such a function does not exist. The match operator is not only used to match against simple values, but it is also useful for destructuring more complex data types. For example, we can pattern match on tuples. So let's define a couple of tuples. ABC equals and hello and world and 42. Okay, let's close the tuple. So we have hello, world and 42. Now let's type in A. We got hello, because if you look at the order of the first tuple and the values in the first tuple, the values are A, B and C. So what happened here is basically the second tuple values were assigned to the variable in the first tuple. So hello was assigned to A, world was assigned to B and 42 is assigned to C. So if I say B, I get world, and for C we get 42. A pattern match error will occur if the sides can't be matched. For example, if the tuples have different sizes. So if I do remove 42, I'll get an error because no match of right hand side was found. Because in the second tuple we only have 2 values and in the first tuple we have 3. So they have different sizes. And also when comparing different types, it gives us an error. So if I go and say ABC colon hello world and 42, let's see what it does now. It says the result gave us an error because we already defined it in the previous state here, ABC equals hello world 42. So it worked for us fine. More interestingly, we can match on specific value. The example below asserts that the left side will only match the right side when the right side is a tuple that starts with the atom colon OK. So let's create a first tuple colon OK and result equals colon OK and 13. Let's run it and we get OK 13. So if I type in result, I get 13 because 13 is assigned to result, that is the second element in the first tuple. But now if I say colon OK colon result equals colon error colon oops, I get a match error, no match of right hand side value found. Okay, we can pattern match on lists as well. So let's try it with list A, B, C equals 1, 2, 3. Okay, we get 1, 2, 3. So if I say A, I got 1. This is the same behavior that is being done with the tuples. So there is nothing different between the behavior of assigning variables between tuples and list. A list also supports matching on its own head and tail. So let's try that. Head, pipe sign, tail. Let's close the square brackets, and so we get 1, 2, 3. 1 is basically the head and 2, 3 are the tail. So if I type in head, I get 1, and if I type in tail, I get 2, 3. Similarly to the HD and TL, that is the head and the tail functions, we can't match an empty list with the head and tail pattern. So I cannot do this. It will raise an error. So I'm trying to pattern match it with an empty list. So I get a match error. The head tail format is not only used on pattern matching but also for appending items to a list. So let's create a list equals 1, 2, 3. We got a list, and if I say 0 pipe sign list, I'll get 0, 1, 2, 3. So a new element or value has been added to the list at the very start of the list. Okay. Pattern matching allows developers to easily destructure data types such as tuples and lists, as we will see in the following chapters. It is one of the foundation of recursion in Elixir and applies to other types as well, like maps and binaries. Now let's look at the pin operator. Variables in Elixir can be rebound. So x equal 1 and x equal 2. So basically we have changed the value of variables, and variables mean variable. You can change their values at any time and point in your application. However, there are times when we don't want variables to be rebound. So we use the pin operator. When you want to pattern match against a variable's existing value rather than rebinding the value, we use the pin operator. So if I try to use the pin operator, which is on my keyboard is shift 6, and x equals 2, it gives me 2. Okay, first let it assign 1 and then try with the pin operator. I get the match error. So no match of right hand side value. Because we have pinned x when it was bound to the value of 1, it is equal to the following, that is 1 equals 2, and we get a match error. So the pin x is similar to 1 equals 2. Notice that we even see the exact same error message. We can use the pin operator inside other pattern matches such as tuples or lists. So let's do that. X equals 1, and let's try the pin operator within the list. X colon 2 colon 3 and equals 1 comma 2 comma 3. So x have the value 1. If I press enter, we get the pattern matching. Now let's try with y comma pin operator x. Okay, and equal, okay, so this is the tuple, this is not the list actually. 2 comma 1, and as you can see we have already defined the tuple above here with 1 2 3. So we have those in the menu. So we get 2 comma 1 and y have the value 2, and x, let's check the value of x. It have the value of x. So if we try to pattern match y comma pin x in the list with 2 comma 2, we got a match error because the value of x have 1. So if I type in 1 here, I get 2 1. Because x was bound to the value of 1 when it was pinned, this last example could have been written as y comma 1 equals 2 comma 2. So this is the same as this. If a variable is mentioned more than once in a pattern, all references should bind to the same value. Okay, let's try the same variable and assign them the same value. So we get 1 1. So if I type in x comma x equals 1 comma 2, I get a match error. In some cases, you don't care about a particular value in a pattern. It is a common practice to bind those values to the underscore. For example, if only the head of the list matters to us, we can assign the tail to underscore. Okay, head pipe sign underscore, close the square bracket, equals square bracket 1 2 3, and we got 1 2 3. Now let's type in head and I'll get 1. The variable underscore is special in that it can never be read from. Trying to read from it gives a compile error. So if I type in underscore, I get an error. Although pattern matching allows us to build powerful constructs, its usage is limited. For instance, you cannot make function calls on the left side of a match. The following example is invalid. So if I try to call in the length function and pass a list to this function, was 3, we get an error. Cannot invoke remote function. Okay, that was all about pattern matching in Elixir, and I hope you have learned the basics of pattern matching in Elixir. If you liked this video, don't forget to subscribe to my channel. See you next time with a new topic in Elixir.